FastMCP3's tool transformation mechanism enables runtime modification of tool schemas and execution behavior through immediate transformation via tool from tool. This approach allows developers to intercept and customize tool operations by wrapping original functions with validation logic while maintaining seamless argument mapping. The upcoming code demonstrates how to create a safe division tool by transforming a basic division function, adding zero division validation through a custom transform FN, and renaming arguments for clarity before registering the modified tool to a FastMCP server. From FastMCP, import FastMCP. From FastMCP tools, import tool. From FastMCP tools, tool transform, import forward, ArgTransform. At tool, def dividia, float b, float, divida by b, return a /b, async def safe div denominator, float denominator, float, if denominator equals 0, raise value error, cannot divide by 0, return await forward numerator equals numerator, denominator equals denominator, safe division equals tool from tool, divide, name equals safe divide, transform FN equals safe divide, transform args equals ArgTransform name equals numerator, b ArgTransform name equals denominator, MCP equals FastMCP server, MCP add tool safe division. This code demonstrates immediate tool transformation using tool from tool with a custom transform FN to modify behavior at execution time. The pattern creates a safety wrapper around the basic divide function by intercepting calls through safe divide, which validates inputs before delegating to the original implementation via forward. This approach separates core logic from validation concerns while maintaining the original function's simplicity. The transformation chain works in 2 stages. First, transform args renames parameters from a /b to more descriptive numerator/denominator for the client-facing API. Then, safe divide performs runtime validation. The forward function handles the argument mapping automatically, bridging the renamed parameters back to the original function signature. This pattern is particularly useful when you need to add cross-cutting concerns like validation or logging without modifying the original tool implementation. The trade-off here is between flexibility and complexity. While this approach allows clean separation of concerns and runtime modification of behavior, it introduces an additional layer of indirection. The immediate transformation via tool from tool is appropriate when you have direct control over the tool registration process, as opposed to deferred transformation, which would be used for tools from external providers. The custom transform function pattern shown here is ideal for scenarios requiring runtime validation or behavior modification that can't be expressed through static schema transformations alone. Let's break it down. From FastMCP, import FastMCP. Imports the FastMCP class from the FastMCP module, which serves as the base class for creating MCP model context protocol servers. This import enables the creation of server instances that can handle component flows and transformations within the FastMCP 3 framework. From FastMCP tools, import tool. Imports the tool, class, and tool decorator from the FastMCP tools module, providing the foundational components for defining and working with tools in the FastMCP framework. From FastMCP tools, tool transform, import forward, ArgTransform. Imports forward and ArgTransform from the FastMCP tools, tool transform module. These are utilities for handling argument transformations in tool execution, where forward likely manages argument mapping to original functions and ArgTransform provides transformation capabilities for tool arguments. At tool, def dividea, float b, float float, divided by b. Defines a tool function named divide that takes two float parameters, a and b, and returns a float result. The decorator at tool marks this function as a callable tool within the FastMCP framework, making it discoverable and executable through the MCP protocol. The docstring indicates the function performs division of a by b. Return a /b. Returns the result of dividing variable a by variable b. This is a simple arithmetic operation that performs floating point division, returning the quotient of the two values. Async def safe dividend numerator, float denominator, float float. Defines an asynchronous function named safe divide that takes two float parameters, numerator and denominator, and returns a float. The function signature indicates it will perform division in a safe manner, likely handling edge cases like division by 0, though the implementation isn't shown in this segment. If denominator equals 0, raise value error, cannot divide by 0. Checks if the denominator is 0 and raises a value error with the message, cannot divide by 0 if true. This prevents division by 0 errors by explicitly validating the denominator before any division operation would occur. Return await forward numerator equals numerator, denominator equals denominator. Returns the result of calling the forward function with the provided numerator and denominator arguments, using await to handle the asynchronous operation. The forward function is executed with these specific parameters, and the result is immediately returned to the caller. Safe division equals tool from tool. Divide creates a tool named safe division by wrapping the divide function using the tool from tool factory method. This converts the raw function into a tool object that can be managed by the FastMCP framework, with the tool inheriting the name and functionality of the original divide function. Name equals safe divide. Assigns the string value safe divide to a variable named name. This creates a simple identifier that could be used later in the code, though its specific purpose isn't visible in this single line. The value itself suggests it might relate to a division operation that includes safety checks, but this line only performs the assignment. Transform fn equals safe divide. Assigns safe divide as the transform function that will process components flowing through the FastMCP server. This function will intercept tool execution, allowing it to validate inputs, modify outputs, or add custom logic while still forwarding calls to the original tool via the framework's forward mechanism. ArgTransform name equals numerator. Creates an ArgTransform instance named numerator and assigns it to the key A in what appears to be a dictionary or mapping structure. The transform is configured with the name parameter set to numerator, which will be used to identify this specific argument transformation in the component flow pipeline. B. ArgTransform name equals denominator. Creates an argument transform named denominator and assigns it to the key B in what appears to be a dictionary or configuration structure. The transform will modify how the denominator argument is processed when flowing through the component pipeline. MCP equals FastMCP server. Creates a FastMCP instance with the server identifier, server, for client identification during MCP protocol handshakes. The string parameter serves as a label visible to clients, but doesn't configure operational behavior. MCP, add tool safe division, registers the safe division function as a tool within the FastMCP instance, MCP. This makes the function available for execution through the Model Context Protocol, allowing clients to invoke it as a tool via the MCP interface. The add tool method associates the function with the server, exposing it as part of the server's toolset. The core pattern here is immediate tool transformation using tool from tool to wrap the original divide function with validation logic while maintaining clean separation of concerns. The safe divide function acts as a transform layer that intercepts calls, validates inputs, and delegates to the original implementation via forward. This approach keeps the base function simple while adding cross-cutting validation at runtime. The transformation chain works in two stages. First, transform args renames parameters for better API clarity. Then, safe divide performs runtime validation. The forward function bridges these renamed parameters back to the original function's signature automatically. This pattern is ideal when you need runtime behavior modification that can't be expressed through static schema changes alone. The trade-off is between flexibility and complexity. While this enables clean separation of concerns and runtime modification, it introduces an additional layer of indirection. The immediate transformation approach shown here is appropriate when you have direct control over tool registration, as opposed to deferred transformation, which would be used for external tools. The key insight is that this pattern allows you to add validation and other cross-cutting concerns without modifying the original tool implementation, maintaining both simplicity and extensibility.
The transform renames the numbers, but 0 still whispers its ancient command.